Thanks to PCBWay for sponsoring this video. When we last discussed screw switches, you out there gave me a bunch of great ideas for upgrades and improvements to what we made. So I want to destroy these and start again. Hello everybody, I am Ben from Team Panic. A comment suggested that these micro screw switches probably wouldn't survive a hit in combat, and I think I agree, so let's test it. Held up totally fine, actually didn't do anything, so this time I'm just gonna throw it. And even that wasn't enough. I threw this as hard as I possibly could into the ground. The switch itself took a direct shot. It's hit in the corner here. It's bent this front pin, but the glue holding this all together has actually worked and has made everything stay together. Now, the final thing to do, of course, is to check continuity. No continuity with the switch open. Let's close it. Continuity with the switch closed. So that has worked and survived that test pretty well. I mean, the plastic casing of the switch got a bit beat up, one of the prongs got a bit beat up, but I would never expect this switch to take a direct shot like that inside a robot, so this should be fine to keep using. However, I do have another version of this that we'll take a look at in a minute. The plan from here was going to be to try and destroy the PCB screw switches using this, my lab power supply. Basically, the whole idea was to try and dump a ton of voltage and amperage into the switches to see if they overheated and burnt or delaminated the PCBs or anything. I even got a little temperature gun to look at the temperature that things rose to with this. But this lab power supply isn't good enough, unfortunately. It is totally able to output 2S voltages, which is what I was planning on outputting. In actual fact, it can go all the way up to about 24 volts, but it can't output any more than 3 amps, which isn't really enough amps to do any of the testing I wanted to do. Most brushless motors that are run in an ant weight, which is where these screw switches would be, will draw more than that anyways. So in a robot is going to be much more of an effective test than this thing is, and that is unfortunate. Also, these alligator clips that I was going to use to try and do this test are underpowered. When I was looking at setting everything up earlier and just plugged in my load, which was just one phase of a larger brushless motor than you would normally use in an ant weight, these cables just got hot. And I confirmed that with my temperature gun here, so none of that, unfortunately, was going to work, which is a bit sad. I was hoping that I could get something more empirical for my testing for how much amperage that these tiny little switches can put out. But realistically, I can't do that, and I just need to look at the resistance on them, which is very, very low, which means that they should be able to handle a decent amount of current. Now that we've failed to destroy the old designs, let's take a look at the new designs, which have some upgrades that they may not even really need in them. So down the end here, we have a new version of the first style of screw switch, which is it has a plated hole and then 2 contacts and the bolt goes through in here. We're going to try and tap this a different way. Again, a comment suggested that a forming tap would be the better option here, and in absence of a forming tap, just running a bolt through it may actually get it to do the job. I've also removed the mounting holes off this because I've added an LED on here and the ground pin to allow this board to be a screw switch and an LED and a power light all in one go, which should hopefully save some weight and space inside, especially ant weight combat robots. I have a new design for a print underneath this as well, which we'll have a look at in a minute. The next iteration down isn't actually a switch on its own. It needs the old style single board as we did in the fingertech style switch last time round. And this is effectively the same thing here, except for rather than threading through the top hole, we're going to actually contact it properly And I looked at this in some testing and realized using a countersink head screw like the one we have here, we can actually make proper contact with the lip of this hole, which means we're able to make this contact just by putting a screw through here and tapping that, and not actually having to solder anything on here outside of the LED, which I've also included on this design. And then finally, we have the third design, which I intended to be the replacement for the 1 pound switch, thinking that it was going to break when I threw it on the ground. It didn't, but we still have a replacement here. So this, we actually need something else brand new. This one is a brass screw, which I think is for leather working. A thank you to Joel, who put me onto these and showed me where to buy them. I just got these off AliExpress. And this is going to be fairly similar. We have a contact patch at the top, and then on the underside, we have a patch to solder on the brass nut. So this should be basically the same thing, but hopefully by using a double brass system, it will have a little bit less resistance to it than the steel screws we're using in the other things, and therefore allow it to run some higher currents, which means it will be useful in the 1 pound division. So this is everything you would need to build one of each of these switches. And if you do want to make these yourself, you now can. I have uploaded all 3 designs to PCBWay's project sharing site, and all the files that you need are up there. I will leave links to this in the description down below. One of each of the boards, 2 tiny little TPU prints which are going to be glued to the PCBs on these 2 iterations and used as kind of a nylock type idea. These brass screws that I will leave a link for in the description, an M3 bolt to use as a forming tool, tweezers to help with seating down the tiny little components, a screwdriver with a good handle on it. I would not recommend using something like a jeweler's screwdriver for this. You're going to need some torque to get the forming bolt in through the PCBs, so a good handle on that. A soldering iron. You can do this SMD style and use solder paste and also a reflow oven of some description that I've covered in previous videos, but in this one I'm just going to use a soldering iron, so we're going for the kind of lower tech, easier option that most people should have the components to do, and a pair of pliers. And then we've got some bolts over here, which these ones are countersink headed bolts, but for one of these you would need a regular flat head of some kind. And then LEDs and resistors, and these are 0805 size, which personally are about as small as I will try and hand solder. There are smaller sizes than this, but these are the ones that I use, and so that is what is on these 2 boards. Oh, and one final thing, super glue, which is in actual fact our first step. I'm going to do these 2 boards simultaneously because the steps for them are practically identical, and it's just going to be easier to do it that way. So the first step here is to glue the boards in place. Starting with the top board, we need to orient the TPU so that this little bump sticks out under where the LED is going to go, so that when we push these across like that, they kind of line up, and that gives you space in underneath for the wires to come out from the 3 connection points here. Lining this up is a little bit tricky, and it's going to get even more tricky when we add a dot of super glue on either side and do that again. This is really the only thing holding this together, but it does not need much. It's not really going to come under too much force or friction. The only thing here is to be very careful about not gluing your fingers to this, which is very, very easy to do. And you should just be able to line these 2 things up and stick them together. Just like that. Now, don't be super worried about the alignment between this hole here and the hole in the base. We are about to try and thread all of this, and the TPU is going to move out of the way. If you're a little close to the wall, that's actually almost a good thing, because again, we're using the TPU almost as a nylock, so the more threads jammed into the TPU, the grippier the TPU is going to be, and the more the screw is going to be held in place. Then we have the same idea with the front switch. We have one little PCB that hooks in here. And again, you need to just kind of line that up as best you can through the hole. But in this case, we actually have two PCBs, so we're going to need to glue this one first, and I would recommend only putting glue on one side, and then putting the PCB in place. The alignment here is a little bit more critical than on the first board that we did, because this hole needs to line up with the second hole that we're about to glue now. Once this glue has had a second to dry, the good thing about using super glue is it does not take very long, especially when you really jam it in there. We now flip this over, apply some extra glue up the top here, and then we're going to line this up so that the back of the board lines up with this back section, and the side of the board lines up with this side section. That should center that hole up nicely and allow us to actually get the board to work the way we want it to work. Again, just a tiny amount of glue here. I've actually probably gone a little bit overboard on this particular piece, but that should be okay. Now we're just going to give these both 30 seconds more to dry, just because the next thing we're about to do is going to put a lot of force on these parts, and we need to make sure that that glue is going to hold before we move on. So the next step is thread forming. We're going to take our bolt, our screwdriver, and some pliers. The pliers are really just to hold everything in place. Now, this is a personal choice, really. However you feel the pliers hold best is going to be the way to do it. I personally hold along this way, even though we're only kind of grabbing this corner. This particular corner doesn't really matter in the grand scheme of things. It's not really a contact point or anything. So while the pliers are probably going to round this off just a little bit in the course of doing this, that isn't actually a huge deal. So this is how I hold mine. And then we're going to grab the bolt, and we just need to touch it in place. And once it's touched in place, we're just going to grab the screwdriver and just start turning. Now, you may hit some resistance. If you hit some resistance, back off half a turn or so, and then just keep going. And if you really struggle, you may need to get a different screwdriver with a different point on it. If you're finding that you are stripping the screw head rather than pushing the bolt through, it could be to do with your screwdriver. Now, also, I will point out here, part of my issue at this point is that I have gone in at an angle. So I need to fix that angle before I can continue, because it's not going to work at any level of angle. You really need to try and force this bolt in straight. Now, it can be easy to do this with a shorter bolt because it is less likely to bend on you as you're doing it. In fact, I am probably going to swap over to a shorter bolt. And there we go. That has got that bolt all the way down. It's actually even come into the TPU, which is what we want. The TPU is never really going to thread properly. Even though I've printed threads into this, it's not really ever going to be perfect as a threaded material, so you don't need to worry about that too much. I will say that the shorter bolt certainly made this a lot easier to deal with, and by unthreading this, we now have a threaded hole. And in this particular instance, I'm not sure if I'm going to be able to show you this, but unlike the last time we did this, we actually have plating still left in the hole. In fact, it goes all the way down the hole this time, which means that we're making a much better contact with our plated through hole here. So this has worked out exceptionally well. And now we're going to do exactly the same thing on the other side. So I did this one from the wrong side. This bottom PCB has kind of lifted up on the edges, which isn't really what I wanted out of this particular part. So threading it from this side is probably the better way to go. And in actual fact, I think, yeah, going forwards, I would just do it from that side rather than this side, because that way the forces involved are pushing down into the plastic and strengthening the glue joint. And I also probably didn't leave it quite long enough. I also probably didn't put quite enough glue in either. But with that, this bolt should now go in here and connect between these two and actually screw into the bottom PCB and make a connection. Now we get to a somewhat tricky bit here. We're going to put on the LED and the resistor. That is them right here. They are absolutely tiny. They are 0805 SMD component. Now, These, as mentioned, you can hand solder these. If you don't feel up to hand soldering these, you can SMD solder them with a toaster oven. That is probably an easier way to do this. It's my preferred way of doing this, but just for this video, I'm going to not do it that way, and instead I'm going to do it by hand to show you that it is possible to do this, despite how tiny and fragile and all that this kind of seems to be. The first thing we need to do is determine the polarity of the LED. I would just look this up online. There'll be a marking on the LED that will tell you either the positive or the negative. The negative needs to go down in both cases here, basically away from wherever the bolt is going through. That is where the negative side of the LED needs to be. The resistor, you don't care. That can go any which way you like. Convention states that you should have the numbers facing upwards, but other than that, that's about it. The LED as well, there is a little like glass thing on top of it. You need that facing up so that the light comes out the right way. Then to actually do this soldering, first I'm going to do what is called tinning the solder pads, and that is literally just to add a small daub of solder onto each and every one of these. I'm also going to take that bolt out. Okay, we have our blobs in place. Some of these are probably bigger than they need to be, especially these lumpy ones. This one here on the resistor is connected to a large solder pad, so it actually takes quite a lot of heat to get that blob of solder in there. You will need to add a lot of heat for that particular one. The rest of these should all be pretty fine. I will also say that while we're here with the soldering iron, we're going to hit these pads on the switch as I did last time, because they need solder on them to make this connection. And we don't need solder on the other pad, but I've got a little bit on there, and honestly, so that should be fine. Now, the trick to this is now that we've got those soldered, I'm going to do this resistor first, and then I will do the LED. So the easiest way to do this is to put a little bit of solder on your soldering iron, move the SMD component into place, and then touch one side to make that connection. Just like that. That's all it needs. That is why you tinned that side to start with. And then we're just going to touch the other side as well. And you should see the solder connect across that, and it should then, in theory, join everything together. Now, we are going to do exactly the same thing for the LED, but unlike the resistor, the LED does have a preferred direction. So we need to do this properly to get the LED in the right way around. I've got it held exactly as it needs to go in. So again, we're just going to do this exactly the same way. LED down, heat on one side, and then we're going to flip it around and heat the other side as well. And that should link that all together and mean that we now have an LED on that board. There's one way to find out, and we'll do that after I have done this one as well. Now these switches are almost done. In fact, you can basically just wire these up as you normally would a switch and everything should work. And we'll do that in just a second. This one, the input is in the bottom, and then the output is out the top, and the ground for the LED is also out the top. This one, all three are marked as they should be, in, out, and ground down the line. But while we've got the soldering iron out and warm, I actually want to look at the third option, this brass option. So this is going to be fairly simple. All I'm going to do, going to effectively screw this screw together through the board to start with. Trying to get it, well, once we get down close to having everything together, I want to get this screw as central as possible, just about like that. And then I'm going to tighten this down with my screwdriver, like so. Then all we're going to do is going to flip it over, and on the back side, we're just going to literally solder this together. So we're just going to solder this connection at the back down to the board. Now this may take quite a lot of heat. There are some very, very large solder pads here. and also this brass piece is going to need time to heat up correctly. But once solder starts flowing like this, you've actually got a pretty solid connection. We're just going to do that basically all the way around, and it should look something like this. This is going to be very, very warm right now, so we're going to leave this alone for half a second, let everything cool down, and then we're going to need to add some solder to the other side as well. Okay, and now that that's sufficiently cooled, literally all we're going to do here is just add more solder to this front edge. Now, as with the last one, this is a large solder pad, so it may need a bit of heat and a bit of coaxing to get it to do what you want. But as long as you get a nice big blob of solder on there, and preferably not one with a lump in it, but because I'm doing this at an angle, that's kind of what's going to happen. Now I can level this out, and that means I can level out this ring of solder a little bit better. There we go. That is looking much better. Okay, before we wire up and test, we're going to do a quick weight check, because once they've got wires on them, it'll be hard to tell exactly. Now, remembering that the old versions were sub a gram without the LEDs and without mounting, really, let's take a look at these. Okay, 1.2 is pretty good for a light as well. Let's look at this guy. 1.06 is really good for a light as well. And then this guy is actually for the 1 pounders, so it's going to be heavier. Yeah, 2 grams. That is easily doable inside the 2 gram class. All right, let's wire these into a power source and actually test that they work. Okay, so as mentioned, I've hooked up just some 9-volt leads to these for now. I don't really want to plug them into a LiPo directly, just to start with at any rate. So I'm going to plug these into a, well, I guess this is a kind of a LiPo. It's a rechargeable 9-volt battery, so technically. We're going to plug that in, and we're just going to turn this screw switch and see what happens. Now I'm going to have to probably hold on to this a little bit. What? Okay. That's interesting. That lit up and then decided not to light up anymore. Okay. That one didn't work particularly well. Let's try the other style. Okay, good. The screw switch is disconnected currently, so it shouldn't be lighting up. Let's try this. Beautiful, lights up, no worries. Unscrew it, rescrew it. That is good. The only thing I don't like about this is the TPU is actually a little bit too strong. I think I might need to increase the hole size in here, because I've got them tapped from Fusion, but I think I just need to have them untapped and, yeah, allow them to not be quite so difficult to turn on, because that means that you're going to have to, like, basically glue this into the chassis to have it be strong enough to survive the force that is needed to turn the thing on and off. Okay, I have tried redoing the solder joints on this a couple of times, and it does seem that it is actually the switch itself which is bad, possibly because the section where the bolt head connects is worn. Oh, whoops. I think I've just burnt the LED out as well. That's my bad. So it seems to be a problem with the LED or the SMD soldering I did. I think it may be the SMD soldering I did for the resistor. If I connect this to the power, which is on the underside, and then touch the output, you can hear the continuity tester saying, yes, this switch is definitely working. So I think it's just this that failed, until of course I touched the resistor to this, which basically shorted the resistor out and put a full 9 volts through the LED and burnt it out. So I need to redo this board anyway, but I'm going to just quickly check to make sure that when I unscrew that it still stays disconnected. So again, into here, into there, cool, nothing. So no continuity, which means this screw switch is working, and if I connect that, that's the screw itself is connected, but the output is not. Perfect. And while we've got the continuity tester out, we of course need to do this. which is this other screw switch we did. So no continuity at all when the screw is unscrewed. But if we screw the switch all the way down, make contact with that solder, we should now have continuity across the switch. Beautiful. All right, that I think is going to be our ant weight switch. And there we go, we have our 3 different forms of the screw switch. Personally, I think I'm going to use this in ant weights 150 grams and these in my 1 pound robots. At least for now, I'm gonna run these as an experiment and see how they go. I don't really expect to have many issues with them, especially as I've run something similar to this already in a robot that was stalling out a brushless motor, so it should be totally fine when the robot is actually working correctly. And as mentioned earlier, if you want to try this yourself, I have uploaded the PCB files and the 3D print files for all 3 of these to PCB's website. There is a link in the description down below. If you do that, let me know. Tell me how all of that goes for you. It would be very interesting to see who does this and how they work for you as well. Anyway, that is going to be it for this video. I hope you have enjoyed that one, and I will see you in the new year. Have a great holidays for anybody celebrating, and yes, see you in the new year.